So we're going to go through 2.3, 7, and 12 on how to do these. So first for this one, the cube root of something is always, rewrite the following expressions with an exponent instead of radical. They don't want you to simplify at all. They just want you to rewrite it with an exponent instead of a radical. So this 9b to the 8th business stays exactly the same. So that's where I start. Okay, and what is the cube root? What does the cube root mean? How do you rewrite cube root in the land of exponents? Well, we just take it to the 1/3. So that is my answer, and it's not showing up here. There it goes. Okay. So there's your answer. They just wanted you to rewrite it with, instead of the cube root function, they just wanted you to do it with the 1/3, which makes sense because look at what happens over here. Okay. So number 12 says the log base 5 of the 5th root of 3,125. So first of all, one of my tactics is, okay, well, what's the 5th root of 3,125? So I'm going to hold off on that. I'm going to first rewrite it using the exponent instead of the 5th root. So I'm going to write log base 5. And I'm going to keep that 3,125, and then I'm going to put it to the 1/5. Putting it to the 1/5. Now, according to our rules from before, right? According to our rules, we know that if we have something to the power here, it becomes a coefficient here. So I'm going to write that as my coefficient out here. So this 1/5 here comes out in the front, and then I just leave the log here, log to the base 5 of 3,125, right? So it just says rewrite with a fractional exponent, then evaluate. So here's me rewriting it with a fractional exponent, and now I'm going to evaluate it. So here, the 5th root, or 5 to the what, gives me 3,125. So in my brain, this part here, I'm thinking, right? This is what I'm thinking over here. I'm thinking 5 to the what gives me 3,125. And I actually don't know the answer to these. Like, some of them I do, some of them I don't. So I'm going to pull up Desmos, my best friend. Not really my best friend, but you know. Okay, so here I'm going to try 5 to the 4th. So I'm going to say 5 to the 4th. What are you? And that's only 625. So I'm going to try 5 to the 8th. And I get way too big. So remember, we were talking about this Goldilocks strategy, like 5 to the 4th is too small, 5 to the 8th is too big. So let me try 5 to the 6th, and that's 15,000. Let's try 5 to the 5th. Oh, it's 5 to the 5th. Okay, so this number here is the number 5. This number here is the number 5. So 5 to the 5th is 3,125. Cool. So that means this whole expression is just the number 5. So I'm going to write that. And then I'm going to keep that 1/5 out there. Right? And then 1/5 times 5 is just 1. So here's my answer. 1. Okay. Interestingly enough, if you were to simplify that, the 5th root of 3,125 would have given you, right, 5. So then you have log base 5 of 5, which is still the number 1. Do you see how it doesn't matter if you use simplifying and then taking the log, or using the properties and then simplifying? It doesn't matter which way you did it, you'd still get the same answer.